Hello? Yeah.
Niet, hè?
optie. Vanuit dat ze iets willen delen. Zou wel handig zijn. Ik heb er niks voor geregeld. Zou wel handig zijn. Ja, misschien wel handig als dat nog even gebeurd is. Ik heb zin om rond te lopen met iedereen te vragen om het nummer van een groep erop te zetten. Ja, maar het is handig vandaag om een plaatje. Ik kan het ook even via de microfoon roepen. Als Ruben dadelijk weer terug is, dan roep ik het even via de microfoon. Ja. En dan regelen ze zelf maar een blaadje. Ja, ik heb hier niks liggen, joh. Ik bedoel, ik weet onder welke schuif jij zit. Precies. Ja, dat mag je doen. Hallo, kun je me horen? Dat was hem niet. Kun je me horen? Ja. Hello everyone, can I ask your attention? Could you also please mention your group number on the table? So grab a piece of paper and stick it on the table or on the board. I see there a nice group 3 on their poster. So if everyone could please take care of that, I would really appreciate that. Thank you very much. Hello everyone. Just an extra announcement about it. We will do the pitches at 10 o'clock, and I would kindly ask you to put if you have any presentation material, photos or a movie, please put them on a USB stick and then we can upload them on this laptop over here. Right, thank you very much.
Test. Test, test, test. Test, test. Ja. Prima.
Good morning, everyone. Can you all hear me? Everyone can hear my voice clearly? And I also hope in the back room, because we don't have any audio installation in the back room, but if I look around me, I see everyone standing in this great, magnificent middle space here of this building. My name is Arnold Koetje, and next to me we have
John de Kwant. I hope you can hear me also. So welcome. Welcome on this day. We are very happy and glad to see you all live together. So on behalf of the team of the supervisors, a very warm welcome on this nice day, your day, because this day would not be there without you. It is all about you, it is all about your results, it's all about what you did. And I think that is something to celebrate today. And that is something for today. Now you have the option to present what you have achieved so far, the nice results, the nice things what we have already seen. And I think it is a very, very positive extra point for this day is that we are here to finish the project of the last 20 weeks, and we did it all together. You did it after Corona time, and we know, we saw it. We started online with the kickoff and the companies and all the meetings we had. A lot of meetings online was not what we aimed for, but that was the limitation of Corona. Luckily, in term 4, we were able to relax a bit in the limitations so that you was able to manufacture and to test your design, and I think that was a very nice period for a lot of you, being able to come here to work together and seeing then what is achieved. I would say it is very great, and then next to the great, I would say nice to have, but more important for that is what did we do? What did you do? What is there on the table? What can you present today? What was it for the company? What did you experience in that time? And take that with you, the positive points of the last term 3 and 4 and this day. And I hope you will enjoy this day, and I would also like to welcome everyone online connected, because we are here about with 70% of the students, and the rest is outside in Netherlands, also joined with us, so welcome. I hope you will also join this day and like this day. Ask your questions online, visit all the online markets also. Anyway, welcome to everyone, and I would say a great applause for yourself to start this day.
So to add to what John just said, welcome everyone, and also a special welcome to all the companies that provided all the assignments for you. We nearly have, we almost have a dozen companies. So in this case, for this year, we have 9 companies who were able to provide some really challenging assignments, and I'll name them right now. So we have Specto Aerospace. So, and I would like to also welcome them with a warm applause from everyone. Femto Engineering. Ion Orbit. And of course the E-Flight Academy. And KVE Composites. AC Light Aircraft, Fokker Aerostructures, Fokker Elmo, both being part of GKN, of course, and last but not least, Saluki Motors. And I hope we now have warmed up our hands, because I'm hoping to hear some more applause later in the day. I think next part of the introduction is some announcements. I think John already sent out an email earlier this week with some extra announcements. So perhaps, John, you would like to highlight those as well?
Yes, that's okay. What then about the program of this day? After this welcome and opening, we will start at 10 o'clock with the pitches. There's one request to all the teams. We would like to have it within 1 hour, so what I have said in the email also, you have 2 minutes, so try to do it in 2 minutes. It's just to highlight your result. Sell it here on the podium. So that's one thing to keep in mind. The other thing is, after all the pitches, and the sequence of the pitches will be just for team 1, 2, 3, 4, I think that's the easiest way to do. After the 20 pitches, a small break, and then you can make up your table and all what you need, and then we start the market visit. There's one request also to everyone. We are a bit relaxed now in the corona limitations, but please keep distance as far as possible and spread a bit over the area so that we have not a cluster of people at one table. That's one thing. The other thing is 12:30, then the live stream will stop, but then we will have the lunch. That's all arranged, you will see that. And after the lunch, the market will go on, but also we have then the feedback meetings with the supervisors to get the feedback and to get your grade. Now, and then around 14:30, we will have the evaluation. We will do that all together here with an online platform, and then you can fill in the evaluation with the help of your laptop per team, but that will be clear and explained later in the afternoon. And then around 3:30, we will finish the day with some drink and snacks. That's the planning. It's I hope you will enjoy it. Explain, tell, show, enjoy. And that is for me for today. I wish you all the best and a very nice day.
Before we start the next mini coffee break, because I think we still have some time for some coffee. And by the way, on the coffee part, we were supposed to get some extra coffee and tea in from catering, but something happened on the way. I don't know what happened, but unfortunately, that will not arrive. So we will have to do it with the slow machine on my right, to the left of you. So please be patient there. I will ask Ruben to start in a short movie with some impressions from the last 5 months of work from all of you. So after that movie is finished, you can relax a little bit, and then at 10 o'clock we will start with group 1. So we will just go through the order sequentially, starting with group 1. Please bring, if in case you have something to show on PowerPoint or photo or movie or whatever, anything else, please bring it on a USB stick. We can put it on the laptop here and then use that. So I hope everything is clear. Before I ask Ruben to start the movie, are there any questions? No? All right, thank you. Then Ruben, take it away. We're going to start the pitches. Can I invite Group 1 to approach the stage, please? Group 1, Specto Aerospace.
Zo groot ben ik ook weer niet, hè? Dus nou, gaat goed zo. Ja? Oh ja.
All right, so we're going to start with the first group from Specto Aerospace, and I'll ask her to introduce herself. In case you do get tired, which I hardly can imagine, we do have some chairs around us, so don't hesitate to grab a chair to sit down if you need to. But in the meantime, enjoy all the pitches for the upcoming hour. Good luck.
Thanks. All right. Hi, everyone. Let me be the first to say welcome all from all the students of Inholland. I'm Max, and with the rest of my Group 1, Eureka, Laurens, Wesley, and Vlad, who is with us today but online. For Spectro Aerospace, we've made a program because they're the leading in sanding radomes and making sure that the composites get fixed. But before they do that, I mean, no one likes sanding, let's be honest. So what they want is to automate that process with help of a cobot, which is a robot arm. And for that, we've made an interface and a color recognition, because each paint layer has to be sanded regularly. And for that, we've made a program based on color recognition, so that each layer can be detected and be sanded properly. At our stand today, we've brought our program, and also to make it a little bit more interactive, you can use our program and check it out for yourself. We've had some Rubik's cubes and other color things that you can actually use our program that we made for Specto. Thanks very much.
Dankjewel. So I think now it's time for Group 2, and I have to check my list here. I'm not sure who knows who's Group 2. All right, Group 2 already presented himself to the stage.
Good morning, my name is Tessa Houtman. I'm the project leader of Team Formulink. I'm here with my colleague, and we are going to give a pitch about our cooling system.
In combination with Femto, we received an Emerson model about the entire electric propulsion system of the Dragonfly. The Dragonfly required a cooling system to be put in place to keep it from overheating. Our team made a variety of tooling, calculations, and reports, and everything to back up our findings and size a heat exchanger for the power of the propulsion system of the Dragonfly. And after that, we tested a few things to verify our results, and everything that can be found at our booth. So,
thank you for your attention.
All right. So Group 3 and 4, starting with Group 3, of course, both for Ion Orbit.
Well, good morning everyone. My name is Theo. I'm from Group 3 Ion Orbit with my lovely group here, Matthias, Yi, Tim, and Tobias, who's joining us online. So do you want to find out more about the future of data communication? Do you want to know how we can transmit data using only light? Well, head down to our stand here later, where you can find out all about it. We can show you the demonstration, a live demonstration which is safe for your eyes. We can explain you all the details, the challenges that are still there, and just see the future of data communication here at Group 3. Thank you very much.
my name is Twan Jokman. I'm the project leader of Team 4. We're also a group from Ion Orbit. And for the last couple of months, we've worked on a laser communication terminal. Yeah, the reason to do this project is because the old radio frequency spectrum is becoming more clouded and clouded by every user. And with the use of optical data communication, higher bit rates and data streams can be achieved. If you want to know more about our technical demonstrator and the project we've been working on, please visit our stand behind the hovercraft, and we'll gladly explain everything to you. Thank you very much.
All right, then the next group is Group 5, the E-Flight Academy.
Well, hello everyone. Just like probably many of you know, E-Flight Academy is building a simulator for their Pipistrel aircraft, electric aircraft. That's the first actually EASA certified electric aircraft. But they want a simulator that can really help with the training of pilots. So they want force feedback in that simulator, force feedback to use the controls. We with Group 5 have been working on a motorized system to control those the stick movements. And I would just suggest to come by our stand or join the online meeting with our group, because we can show you way more than just in 2 minutes of a pitch. So we with Group 5 would like you to join us at the simulator somewhere today and come and fly. We have the simulator running, so you can come and fly. And yeah, I think that's all I have to say.
Next group, Group 6, KVE Composites.
Hello. Closer. So we had to design a tool that would help us to weld such a rib in such a little area. Imagine this is an aileron. So firstly, we designed one tool, and it showed to be very promising, and we were very happy. However, after doing some stress calculations, it turned out it's really not going to work. So we brainstormed again and came up with a really promising tool. And in theory, it works, in practice as well. However, in the final product, it hasn't been tested yet. But you're welcome to take a look at it, at some of the components we made, at some of the mishaps we had. So please come by our stand, stand 6, and take a look.
Then the next group, Group 7, AC light aircraft. For this one, we have a small video. So bear with us for a second while we start the movie.
So, good morning, everyone. So, I know that in the aviation industry, we have the constant need to innovate because we need more efficient parts. So, in order to respond to that challenge, we at Group 7 at Modular Gear Solutions have decided to produce a landing gear courtesy of the supervision of our company supervisor of AC light aircraft through Mr. Evertjan Cornet. So yes, and now our booth is there with the party lights. Feel free to join. And there's also a QR code for our public relations kit, which you can scan so you can actively learn more about our product. And we have a product demonstration there later. So for now, yes, we have a video to present. So this is basically our journey, the summary. Thank you. So basically, yeah, so you can see it later as well. There's no volume, so, but yeah, this is what we did. So this is a journey. So preliminary design reviews, the PDR, so we did present. So it's a slow journey, but yes. And yes, we did company visits, we research, and of course, a lot of trial and error. We would hit roadblocks, etc. But of course, we pushed through. We tunneled through it. And yeah, our designing processes, you can see there as well. And of course, load calculations. There's no engineering without the theories and the load calculations. And of course, the building. and the testing, which is there. You can test it yourself. We can demonstrate it. So there. Thanks for watching.
Can we copy the movie and then play it next time with music? Yeah.
Hello everyone, can you all hear me? I need to put it up a bit. Hello, we're from group 8 and we designed the cowling for the Dragonfly. As you all know by now, the Dragonfly has changed to an electrical engine and therefore the cowling needed to be changed as well. For the last 20 weeks we designed and manufactured the cowling. Here's a little scale model of the cowling. If you want to see more about it, please come visit our stand and we can tell you everything about composites, mold, sanding, for example. We did a lot of sanding, molds, plugs, and composites. So please come by and we tell you everything about it.
All right, so for the ones that didn't realize, that was Fokker Aerostructures, and the next assignment was Fokker Elmo, which is group, not sure which group that is group number 9.
Hello everyone, we are group 9 and we have worked on the electrical wiring system for the Dragonfly and then mostly just on the electric propulsion part of the Dragonfly, and we focused mostly to make it as redundant as possible, to have both the engines running apart from each other. If one would go out, the other would still be able to go on. And well, how did we actually verify that it was redundant? We made a test setup, which is visible on our test stand right there, and we made it interactive, so you can actually switch the different contactors for a tiny engine right on our stand yourself. And we would like to thank Inholland and Fokker Elmo for the opportunity to work on a zero emission flight. Thank you for listening.
Right, the next group is Fokker Aerostructures again. Group 10. Nou, ik wil hem even aan deze kant gaan. Dan moet je hem denk ik omdraaien.
Eens kijken, dat is beter. So, good morning everyone. We're group 10 for Fokker Aerostructures. We worked on the AeroSeal. The project team consists of myself, Viola, and Alexander, Adil, and Heinrich, who are currently online available. My colleague will tell a bit more about the project itself.
Yes, thank you, Sven. So we had this assignment where we needed to design a closing of the tab, which is around 10 centimeters, but it needs to bend and it needs to be flexible. So that was the assignment. We came up with a corrugated structure out from 15 concepts. Those concepts were divided in 3 main concepts: concepts from the nature, concepts that are 3D printed, and concepts that are being placed hydraulic. So those were the concepts, and Sven will tell more about the test and how we did it.
Yeah, so we used various analysis, both static and dynamic. We verified those by manufacturing the part and testing it. For any extra information, please come by our stands, and we will happily go into further detail. Thank you.
Thank you.
All right, so the next group is Group 11, which also did an assignment for KVE Composites. Group 11.
Hello everybody, I'm Akif. I'm from Group 11 and we did in collaboration with KVE, where we made a detailed design and a verification method of the composite thermoplastic aileron for the Dragonfly, where we designed the lug using topology optimization, and where we looked in a different way of bonding the look together with spar. Instead of using bolts and screws, we have looked in using adhesive. And what makes this so special is that this bond is between titanium, the lug, and the spar, PPS. So if you are interested in our results, just come look at our stand right there. Thank you.
So what I'm seeing here, can you hear me? Yeah, so it looks like this is an aileron from the Dragonfly, made from thermoplastic material, if I'm not mistaken. And here you can see how it's actually manufactured, because that's actually quite a challenge if you want to automate that process. And you want to use induction welding, as KVE is doing. They have patented the technology for that with using a robot arm. Well, that's quite a challenge, and I think that's what this Group 11 did a good job on. So thank you. Oh, I see some coupons were tested. Oh, it's 4 minutes long. Okay, so then I'm going to stop the movie, but we're going to put it online, or we're going to share it in some other way. So, but in the meantime, again, thanks Group 11, and we go to the next group. Which is Fokker Aerostructures.
Well, good morning, everybody. My name is Mark from Group 12, and our job was to investigate the possibility of using extremely thin aluminum material for aircraft skin section, primarily considering the tail section of smaller aircraft like the Dragonfly. For this, we primarily tried to design a test setup in which we could mimic the behavior of what you would expect on the tail section. If you want more information about this or see the video of the results, then please visit our stand where we can show you all the results we had. We managed to design 2 different test setups where we tested the material itself for buckling failure and how we could actually improve the structure with stiffness and all that. But again, if you want more information about it, please visit our stand. Yep.
Ruben. Thanks, Mark, from Group 12. And next group is Group 13, who did an assignment for the E-Flight Academy. And it looks like they're going to present something on screen as well, using PowerPoint, if I'm not mistaken, and also a clicker. So bear with us for a second while we start everything up. And I would like to invite Mace and Martin first on stage. Martin, go ahead.
All right, thank you everyone, and good morning. Just hold it. All right, good morning everyone to our pitch about E-Flight Academy and the development of the Pipistrel flight simulator. We are lucky number group 13, and we did this assignment in collaboration with E-Flight Academy. E-Flight Academy is an electrical flying school in the Netherlands located in Teugen. And this electrical flight school, they operate 2 Pipistrel Velis Electros. So what is a Pipistrel Velis Electro? It's a 2-seat aircraft with an electricity motor, of course. It can reach a speed from around top speed of 180 kilometers an hour and has an endurance of around 15 minutes. So what exactly is the problem then? So the problem is, for a flying school, is that there are no really certified general aviation simulators. So when you go to a flying school for your PPL, you might encounter here on the bottom left some sort of home-built simulator, or if you continue in your flight career, you encounter a multi-million-dollar fully certified 737 simulator, for example. So at the moment, there's not really an affordable solution to provide simulation training at flight schools. So what is the solution then? A solution would be an affordable flight simulator that offers similar viewing angles and seating positions with high quality VR, with in the future control loading on a motion-based platform. So I've got a small movie here from Arnold, looking good, enjoying the simulator for the first time. So as you can see, it has integrated virtual reality in it. The seating position and the viewing angles are really similar to the original airplane. So if you want to have a look later on, the whole setup is working. We're located at a very fortunate position next to the coffee machine through that door. And we can answer all your questions. And another thing, smile guarantee. Come fly with us, have a look through that door. We tell you all about control loading, tell you about electrical flying, tell you about control loading, and see you in a bit. Thank you very much.
Thank you, group 13. And then the next group is group 14, who also did an assignment for AC light aircraft. Can I invite group 14 to approach the stage, please? And while Martin is arranging the technical stuff on the microphones.
I think this is a bit easier to just leave it loose. So yeah, we're group 14. We've been working with Eva Jean Cornet, also at AC Light Aircraft. We have also been working with group 7 over there. We have worked together to integrate their landing gear into our wing spar for the home-built aircraft that Evert wants to be made. This home-built aircraft, what Evert wanted was a wing spar that could be removable and also be made out of composites. But with a wing spar, of course, there are complications and that need to be tested and manufactured and all that kind of stuff. So we did that, of course, and with what we did, we want to ask you to come to our group or to our table to see what we have made with this incredible wing spar and with this incredible project, and yeah, see how we did it. That's all.
All right, then I think it's time for the next group. I think it's group 15, which is the other group working for Femto Engineering.
First of all, good morning and welcome to everyone. I am Telden Lotter and I'm part of Group 15, Green Thermal System Solutions. Like many others here today, we have worked on the Dragonfly project. This project is about making the aircraft airworthy again and with new innovations and a new propulsion system more green. For this, we have done broad research into possible cooling systems for the Dragonfly. And together with cooperation with Femto Engineering, we were able to simulate the thermal behavior of the Dragonfly. For this, we have made a preliminary design stemming from the design requirements we found. And we designed a heat exchanger, which we actually validated here at Inholland by using a wind tunnel. We would love to invite you today to come and take a look at 11:30 and 1:15 to see if it actually works. We're just to the left of the Dragonfly and we would love to see you. Thank you.
All right, then group 16, also an assignment for Fokker Elmo, GKN Fokker Elmo, that is.
All right, so good morning everyone. My name is Martin Moy, I'm from Team Spark. And for this project we were assigned to develop the electrical wiring interconnection system for the Dragonfly aircraft. We focused solely on the avionics and the flight instruments part of the aircraft, and the other group they did the powertrain. We started off by making a 2D diagram, connecting all of the components together, and we physically located all of the instruments inside the aircraft. And with that combined, we were able to make the wire lengths and to determine them. And with all of the data combined, we were actually able to manufacture the wiring harness for all of the avionics and the flight instruments. And the best part about it is it actually works. So if you're curious and want to see all of them work, then please feel free to visit our stand. It's right in front of the Dragonfly. And yeah, thank you for listening and have a nice day.
If you want to fly electrically, you need an electric motor, and that is what two teams did for Saluki Motors. And now we have group 17. Being Stefan, who's putting in some USB stick, probably to show something. Ruben can start some background music in the meantime. That'll be okay. You can rotate the laptop, Stefan, if you want to see what's on the... Yeah.
Yes, good morning everyone. Let's see if it's working. Can you guys see the screen? My name is Stefan. I'm from Group 17, also known as Sitten. We've been tasked with designing a new outer housing for the Saluki motor. I don't know if it's switching to another slide. Some technical difficulties, but it's fine. Yeah. Okay, great. So, their current design is made from machined aluminium, which has great thermal and electromagnetic properties. But on the other side, it's also a quite costly process because the aluminium obviously has to be machined, and it's a lot heavier than it could be. Another side of the design. So for a new design, we opted for a carbon fiber inner and outer shell and a foam core. Also, to maintain the electromagnetic properties, we want to incorporate a copper mesh. You can also see this at our stand. For this specific part, it would save up to 90%, and for the overall housing, it would save 13%. We've made a show model to test out manufacturing possibilities and to look into the properties. We've also made molds to obviously test the manufacturing possibilities. You can also see this at our stands. And yeah, I would like to thank you for your attention, and please come by. And we've got cookies, so...
All right, not sure if you can hear me. Yes, you can. So now it's group 18 that I'd like to ask to approach the stage, please. And again, some footage using the laptop. Almost there. And it's a great view back here. I'm actually seeing your lunch here being placed on the table. And I can assure you it smells really good. All right, Stefan. Oh, sorry, Niels. Floor is yours.
We're Team Galgo, and we're doing the Saluki motor housing project. In this project, the goal is to reduce the weight of the motor housing. We did this in two ways. We're reducing the volume with a different shape, and by changing the material of the rear cover from composites. And this will be the main focus of our manufacturing and testing. During the testing in this video, you see the process of making a rear cover from composites, which is done by hand laminating. In the video you see a short time lapse of how it is done, but the principle is by using a 3D printed mold, you can laminate different layers of carbon fiber with the desired resin. We produce various results and various samples with it. In the video you can also see the vacuum bag where it is cured in the oven to resist the temperatures of the electric motor. The final results are visible here. We created 9 samples in total, each with a different process, different ways of producing. And we welcome you to see them at the stand, where we can tell about the different samples we produced. This was our pitch.
All right, so thank you, Niels. We have 2 groups to go, almost there. Group 19 is next, which also did an assignment for Specto Aerospace.
Yes, good morning. My name is Lawrence. I'm from Group 19 for Specto Aerospace. As you know, Specto Aerospace is looking into automating their sanding process with the use of a cobalt robot, But we all know we can't just leave robots alone. Someone has to check on them. So we looked into creating a monitoring system that pairs with a robot. And because of our output is the input for group 1, the color recognition, we looked at a couple of ways to improve this process by, for instance, creating a program that stitches the images so we can make multiple close-up images and stitching them together as one. And also looking into a program that removes the background from images. If you want to know more about the project and how it went, table 19 is the place to be. Thank you.
All right, last group, group 20. Also an assignment for Fokker Aerostructures.
Good morning, everyone. I'm Liam Buck. I'm the project leader of Cohesion Engineering. In our group, we have Deshaun Richardson, and giving our pitch today is Michiel van Groen.
All right, hello everyone. As we all know, greenhouse gas emissions are a major problem in current aviation, and therefore eyes are set on short-term feasible technological developments as we wait until green fuels are implemented in our industry. So we just, together with Fokker GKN, we designed, developed and tested an aerodynamic seal that allows morphing of the aileron, which included a couple of major contradicting factors, such as being stiff and flexible at the same time. If you want to see and even experience how we solve this contradicting factor, come to our stand. It's over there. And yeah, we would like to have a discussion with you guys. So come over.
Thank you for your attention.
All right, so those were the 20 groups. We all heard their pitches, and I hope it gave a good idea about what they worked on. And I think for the next roughly 2 hours, we have the project market. So that will take until 12:30. At 12:30, I would like to invite everyone for lunch. It's already placed in the back, but we will start the lunch at 12:30. So until then, we have time to mingle, to ask questions to everyone, to give some good ideas, and share some good ideas, of course, and you know, make it a fun time as well. So good luck, and perhaps in the meantime. Oh yeah, what I forgot to mention in the announcements round at the start is that we also have a reporter, Rick Westerink. He just entered the building, and he's going to walk around. Do you want to say something, or no? Sorry, then I understand. The microphone is not on yet, but Rick will walk around as well, and he also will be asking some questions, and he will also bring a cameraman, Dennis Mulder, who's standing behind the camera over there. So please be aware that that will also happen. So that is Rick Westerink, who's going to do that, and he's standing over there. All right. Thanks, everyone. Good luck. Perhaps some music in the background in the meantime, and then good luck, everyone.
Yeah, that doesn't help, does it? Okay. Sound okay? We will be starting with the interviews soon, so we're gonna walk by all the tables. And Ruben, can you hear us? Yeah? Both mic, perfect. Okay. Ja. Maar wanneer gooi je ons live? Okay, we're live. So, welcome. I'm Rick. I'm your host, giving everybody at home the opportunity to see what the students or your colleague students did. So, I want to start with Saluki Motors. There's two student teams here, and let's see. Can we interrupt? And is there somebody willing to explain what you've done? Okay, what's your name and yeah, what have you done?
We're from the student team, Team Gogo, and we're working on the Saluki motor housing, where we designed various composite samples, visible on the table here, which are suited for the Saluki motor. The motor is currently sitting right there, and that's where we're designing this cover from composites for. It's a relatively light sample compared to the original aluminium cover. But this is not the best one to see, but...
Can you maybe first show where this cover goes?
Yeah, so this cover goes on the housing.
You can also look at the engine there. There's the engine is placed.
Maybe we should start there. Huh? Yeah.
Start there. Okay. So if you actually look here, you can see this is the entire Saluki engine. It's just placed right now. So we also see it for the first time. As you can see, we got this the same part for the electronics housing, and we, as Team Gogo, has designed a new rear cover. This rear cover will actually be much more lighter, stronger, and when it's scaled up, because this is a very small engine, when it's scaled up, it can reduce the weight significantly. So around 80% is this weight being reduced. So we also produced many samples. In our process, we had some hiccups. Some successes, but eventually we got the best product and solution to develop a nice rear cover. And yeah, the rear cover is very light and strong.
And can you explain a little bit about the challenges you faced?
There were a couple of challenges, as you can see maybe on the table. We produced 9. From the 9, like 4 of them failed. As you can see, some parts stick down. The process of laminating, we all did it by hand laminating. So the process was a little bit new for us, but during our producing of the composite plates, we find the right way to do it. And maybe the thickness can be improved also. So maybe if the plates are a little bit more thinner, it can be significantly decreased down. But yeah, we also printed the molds ourselves. We 3D printed this, and we applied our techniques to make it ready for the composites. Yeah, so in general, we applied many samples and actually found the best solution to replace the rear cover. The other part we also wanted to do was the top cover. As you can see here, the top cover has also been changed quite differently. We advised the shape to the owners of Saluki. To actually reduce much more weight. So we only focused on this project, mainly on the rear cover, but we also introduced the top motor housing. So yeah.
And how did you validate the design? So maybe you can explain how you validated the design.
Yes, well, we validated the design by placing like weights on the inserts on the part where the weight is coming from. And then we did like a lot of kilos and weights on it, and it could handle like 30 kilos. So that's a lot because it only has to handle like 1.5 kilo. Yeah, like 1, 2.
The whole engine only weighs like 17 kilos, but the rear cover plate only stored like 1.2.
Yeah, so it's an overkill on strength. So we can like reduce it a lot in weight and in thickness. Yes. So that's nice.
So where did you work on this project? Did you spend some time at Saluki, or was it mostly within in the lab?
Yeah, it was mostly within the lab. First, we did it a lot from home because of the corona time, and that was a lot from the computer and a lot of research. And then we went a lot to the composites lab at Inholland, and that was to make all the composites actually. So it was the right place to be.
So what was the most difficult part?
Oh, the most difficult part was like the timing and the planning, because it took a lot of time to get even the molds done and to know which coatings we had to use, because as you can see, some were not like correct because they were not able to release it from the mold. So it was a lot challenging to know the right materials and components to use. So we did that by a lot of experience, by just making them.
Yeah. So in the end, are you happy with the results of the project?
Yeah, we learned quite a lot. It's pretty nice to make the samples yourself if you do some research first and then see what you can make from it. It's a good application of the theory in physical work. That's a good thing to learn from.
Yeah, and Saluki Motors Maarten is here as well, but I think he just walked away. But there is actually two teams, so thank you very much, and then we'll go check out what the next team has done. Yeah, so walk a little bit in this direction, and can we interrupt real quick and maybe do the interview? Yeah, is that okay? Because there's no choice really, is there? So can you explain what you did for Saluki?
Yeah, so we redesigned the top part of the housing to reduce the weight. We did this to replace the material with a composite with a foam core and with a layer of copper foil in it to make sure the electromagnetic shielding property of aluminium is still taken into account.
Yeah, because the top cover is right here, right? This is the part that you redesigned and prototyped actually. So what problems did you face during your project?
A lot actually. Maybe you can tell a bit about the problems.
The most of the problems just lay, I think, in the 3D printing, because that went wrong a couple of times, and you have an idea, but it's not always just relatable to the topic as that you think it is. So I think that were the most difficult problems, and maybe if you
perhaps, not having all the tools in-house. So, for example, machining foam from a composite part was initially the idea, but we did not have a large enough CNC mill, so that was already not possible. So now we kind of intruded the foam between the copper layers.
Yeah, you can take a look at it if you want.
Maybe you can show. Yeah.
So now foam, intruded in it. And now it's 230 grams instead of more than 2.5 kilograms. So the weight reduction is more than 90%. So that's good. And overall, that means it would be 30% of the whole housing weight is reduced. So that's quite successful.
So the 3D printing was really for the molds. Is that
it would be ideal to use, for example, an aluminum mold because you can reuse it. But the toughest part about the inner copper carbon layer is because it's a 90 degree angle compared to the flat surface on the ground. So it's very hard to release the copper layer from the mold. So.
And how did you come to this design, and how did you select the materials?
Good point. It's a lot of research and looking into possible groundbreaking ideas.
But we didn't do anything about the design itself. As you can see, it's just the same, if your hot is against it. Because Saluki has some characteristics and they want to keep that. So we didn't do anything about the design. That's why we put a layer of foam into it, because it's just as thick as that design. So it can just be parted to the other group, their design as well. So that's handy.
It should be able to right away be included on the housing, on this current housing, without any major changes. So.
And what did you enjoy most about the project?
Yeah, I think some more hands-on experience with copper, and yeah, learning a lot about electromagnetic waves, etc. It's quite interesting as well.
And a lot of sanding. We like the sanding.
And you're president of SIP Cabinia as well, so how is combining those tasks together with this project?
I'm just next year president in the Lustrumyear. So next year we have our Lustrumyear of the 55 boards. So it's all fine to combine it these days.
This year she has still time, but next year she will be yeah, representing our association, SIP Cabinia.
Yeah, perfect. Do you have any idea about how this project will continue?
Yeah, it's a bit depending on what yeah, the CEO of Saluki will think. He was quite pleased with the project or with the parts, so I think he can do some more testing, but at this point I don't know if it's directly will be continued, because it's quite hard to make it automated, the manufacturing process at least.
Yeah.
Well, perfect, thank you very much. And I think we'll go on a quick break. Do I want a cookie? Yes, of course I would like a cookie. Who baked them? Oh yeah, yeah, he will take on. We'll take a quick break. Ruben, can we take a quick break and then we'll be right back with another project. Oké, zie je nog portaal? Ja, alleen ik denk niet dat het zo kan. We hebben een setting. Oké, we zijn weer terug en we gaan verder met de presentaties. We lopen naar de volgende, dat is Geke en Fokker. Goeiedag, zijn jullie er klaar voor? We zijn live. Hallo, ja, zouden jullie even snel kunnen voorstellen en een korte beschrijving kunnen geven wat jullie gedaan hebben?
Ja, zeker. Ik ben Michiel van der Groen.
Ik ben Liam Bak. En we hebben een aeroseal ontworpen voor Fokker.
Oh ja,
kunt u
sorry,
daar-
we have to do it in English. So,
Oh, we have to do it in English.
sorry, I keep forgetting, but part of the audience is English, so we're going to start over. Can you quickly introduce yourself and let
I'm Liam
let us
Bak.
know you? Yeah.
I'm Liam Bak. We're Group 20. We're Cohesion Engineering, and we designed an aeroseal for Fokker.
Yeah, I am Michiel. I'm just a project member.
My name is Deshaun Richardson, also a project member of Cohesion Engineering.
And what was your project?
So we designed an aeroseal for Fokker, and what that means is you can see it on the board right here. With a control surface, the Fokker designed a hinge that has the rotation point located at the top skin. This means when the control surface is deflected in positive or negative direction, the skin needs to deform. It needs to
we're talking
elongate.
about this portion, right? Yeah,
so
maybe.
We're talking about the green line.
Yeah.
And this needs to be sealed off from any air that wants to go into the structure. It needs to elongate and compress while still maintaining stiffness out of plane. So this direction would be the air pressure, and it still needs to elongate and compress enough. We did this by using a 0% honeycomb structure. The structure can deform and elongate due to this shape that was designed, but still has enough height and moment inertia to make the deformation out of plane from the air pressure minimal and comply to the requirements.
So we have different test setups here. Do I see this right? So
Yes.
maybe you can.
So this is more of a demonstration model. Here we have an elongation and compression setup, and here a tap angle setting test. So I don't know. We had some trouble with the electric setup. I don't know if we can demonstrate.
It shows the compression pretty well, but for the elongation part, you don't actually see it that much because the motor doesn't take it down too much. But we can still show you guys the counter, and it'll be perfect, actually.
Yeah, wanna see that?
Yeah. So this will be the elongation of the. All right. So you see that they still have the shape as illustrated more or less here. And this is in the compressed position, as you can see. It also shows the setting of the tab angle. Yeah. Yep.
So what was the challenge of this project?
Well, it had to be flexible enough to actually reach the tab angle settings, but then, like my colleague said, also stiff enough to resist the aero loads on top of the structure. Finding the materials and the principles that can actually do this was the challenge, actually. Yeah.
And how did you come up with this design?
Extensive research, yes, and some FEM simulations. Michiel was in charge of this.
And the materials, how did you choose the materials?
Also from literature research, we saw that they had ABS plastic, for example, so we decided to use PETG, which is also a plastic, and yeah, it worked pretty well. Like, for example, this test specimen, this is one of the first samples we made, and it took like about 500 newtons to actually completely plastic deform it and break it.
So the prototypes are of the actual material?
Yeah, that'll be up to the client to decide. They can still probably change the materials if they like, but in general, the principle, it still works, you know. You can still see that it elongates, it compresses, and it's strong enough, as you see here again, to withstand the aero loads. Yeah.
Because your customer is right here, isn't it?
Yes,
isn't
he is right here.
Yeah.
Yeah.
So
here
how
I
did
am.
you experience the project?
Yeah, I experienced this very positive. So we knew that it wouldn't be easy. It is a rather tough subject because we have been thinking about it for alongside our work for over a very long period of time.
Yeah,
And
how
we-
long?
Well, we are busy with this concept, with the morphing concept for more than 3 years now, 3-4 years. So in the meantime, we also had to think about a solution for that, for this aeroseal. We also had a thesis student working on it, so we knew it wouldn't be easy. So also the thesis student didn't come up with a real good solution. So I think it's great that that this group can show this result as they do here at the stand.
Yeah. So what is the value of the results?
The
for
value is that we have a morphing concept, as is shown here, as displayed here, which has a closed skin at one side of the wing profile, and the other side is moving because the hinge point is inside of that top skin. So the other side is moving. So you have to have a special seal that will breathe along with the reduction of the gap and the extension of the gap. And it also should have some aerodynamic shape, of course, to optimize the profile. So, and there is a challenge with respect to the fact that you have to be able to elongate, but you also have to keep from the other side, from the perpendicular side, the air pressure. And so there is a contradiction inside this mechanism. And that contradiction, therefore you have to come up with a good solution. So in one direction it should be flexible, in the other direction it should be reasonable stiff to maintain a good shape. And so that is a challenge.
And you had a certain expectation, I'm sure. It's
Of
the
course.
first time you work with Inholland on a project.
For
like
us,
this?
it's the first time.
Yeah.
We had also 2 groups, so 2 competitors, and both groups did very well, and they have, not really same results, but it worked out well also for the other group. So that is also a possibility to for a future project to work it out and to bring it at a higher level, so to speak.
Yeah, so you see continuation of this project?
Yeah, probably. Yeah, and maybe also at Fokker, maybe with a thesis student or an internship. So there are possibilities to continue this work.
And what do you see as a possible application for this?
At the moment, we are developing our concept, our morphing concept, in Clean Sky, in a Clean Sky project. And there is at this moment interest from Airbus also for this concept. We also have to wait and see how serious it all is. But certainly morphing is going to be part of future. So there will always come a point that there will be an application for this solution. We really believe in that.
Sounds like a great contribution.
Yeah.
Did you also have some difficulties? Corona was still in play.
That is. So it was somewhat difficult in the communication. So everything had to be done on the web, and we were also afraid that it was not possible to really make these demonstrators. But finally, there were possibilities to join here at Inholland and to go to the laboratory to make these demonstrators. So, and in the end, everything worked out well. And I think it's also becoming part of the future that we are working more at home. Also at Fokker, we experienced that. So it is very well possible to do tasks at home. But of course, you need also to spend time at the plant to have contact with your colleagues for the informal contacts. Informal contacts can also speed up developments, so that is what we experienced. And I think the same is the case within this group. So they had to meet to speed up things. And fortunately that happened in the last month, when also these demonstrators had to be produced. So then the group gets interactive and then things happen. And it was very nice to see. It was very good to see.
what do you see as a difference? You working with engineers that have been working for a long time, and students that come with maybe a new mindset.
Of course, it's always good to have fresh people inside because they have fresh ideas, new ideas. Sometimes you think, I never thought about it, but could it be worth something? But in the end, it also always works out well. And what I recognize in the process is that is also at we are somewhat more experienced engineers. Every time when there is a new subject, it is very broad, and you have to make steps to come to a final decision. And that is what I have seen here too. So in the beginning there was a long range of concepts. They had to make an assessment of it, and they have to find the number one concept to work out. Yeah, and it is all very recognizable. That is also how we approach it at GKN Fokker. So.
Yeah, perfect.
So they did it very well. All recognizable, and they were somewhat uncertain. They have to get used to that. But it worked out good.
Yeah, the first project, but not the last.
Probably not.
Yeah, that's great.
So we are thinking about the next job, so to speak.
Okay, great. Thank you very much.
You're welcome.
Okay, let's see who else we can get. Maybe here in the corner. I think it's quite a success. Everybody is busy talking to people. Can we break in for an interview somewhere, or is it? Is it possible? So maybe over here.
That's fine.
Great. Yeah. Well, can you introduce your team and quickly explain as well
We
what
are
your project was about?
Group 1. We are working for a company called Specto, and we designed a software. So a radome has a lot of paint layers, and those paint layers are currently removed by hand, but they want to automate that using a robotic arm. And we wrote a software which is capable of detecting the different paint layers within the radome, so it knows which layer has to be sanded and which layer can be sanded. For example, the composite layer, which you don't want to damage. So our export will be an image with a go and no-go zones for the sanding robot. And later on they will hire someone else to transfer the image from our export to the robotic movements of the robotic arm.
Yeah, so you have some hardware, I see. Did you have to specify that, or was this an existing system that you worked with?
No, we designed everything from scratch. So we started with a blank Python script, and then we started with different trials and errors, and we came up with multiple different windows. So we have an initial window, a setup window, where you can fill in, for example, over here, where you can fill in all the different layers. So for example, currently I've set it to 4 layers. But you can change that to 12, for example, and then it will just add a few extra. And that way the software knows how many layers there are in the radome and how much it has to send. And then another image can be used. This is the following window. This is the calculation window. So over here, from the input image we receive, we calculate the different areas. So the go and the no-go areas, which will look something like, let's see if I have some export images.
Yeah, and I see a Rubik's Cube here. So how is the Rubik's Cube?
We cannot bring an actual radome here to test, so we decided to bring a lot of colors that you can test yourself to see whether the program really works, to see how the color detection works, and it's just nice as an interaction with people, with the guests here. So you can color your own radome, or you can take a picture of yourself and see how you could be sanded. That was an idea. Yeah.
So can you do a quick demo? Is that possible?
Certainly.
Will it take a little bit more time?
Yeah, we have a camera here. What would you like to send? Just.
Okay, that's
you can take a new picture, maybe.
I think so you're doing the setup right now?
Yeah, so we start with, let's see, we clear all the images. So right now the import folder is empty, as you can see over here. Then we start taking the first picture of the Rubik's Cube. So we can press the phase 1 button. Now the first image is taken. And then we open the first image, so we can grab the orange color, for example. So we hit the layer 1 button, then we hit the orange, so this turns orange. Then we can adjust the sensitivity slider. For now we only use one color because there aren't multiple colors on the radome currently. Then we go to the next window. And over here we select the folder which is used as an import folder, so where all the images from the other group we receive are located. Then we select this folder. And as you can see, the first one is the import folder. The second, this window is the detection software. As you can see, it does not only locate the orange, but also a bit of the table because of the high sensitivity. So we can decrease the sensitivity a bit more. And that way it should be more precise when we run it again. No, not really, but still the orange is detected. Then we can, for example, run the program. So it's now currently watching the folder if a new image appears. So we can move the Rubik's Cube to another place. And we take another picture. And then it updates over here. And it recalculates the image over here as well. So it also detects the orange from the letters, for example. Then this image is useful for the human eye because it's nice colors. But the robotic arm doesn't want colors. It wants to straight up, can I send it or can't I send it? So we have another folder, which is the export folder. And in here, we have a binary image of the different zones. So black in here is the no-go zone, for example, the composite of the radome. And the white areas are the go zones, which has to be sent. So these are our results so far.
So, were you able to test it at Spectro?
We did some tests with some test images, but because they didn't have the right import for our program, because we need images with perfect lighting. For example, you don't want any glare or discoloration of the image. We couldn't do a completely verification, but we did plenty of tests to verify that the program works properly.
So it needs some more work before it will work in a production environment?
Yeah, because also the export still has to be managed by someone else. That's not our scope of the project currently.
So are you happy with the results and how far you made?
Yeah, I'm definitely happy about it because we got a short amount of time and we delivered an actually working program with a nice interface. So the company supervisor was also very happy about the results.
Yeah. And what's your biggest challenge?
I think for us mostly is the programming itself because we are not really seasoned programmers. Lawrence maybe is, but still not on a professional level. So we have to start from scratch, learn how to do it properly, knowing what the customer would want and not would like to have because the customer itself don't really have an idea of where to start. So we have to be the basic for it. I think that's the most important part. We're filling in a gap where the customer doesn't know how to. So yeah, we have to find a way.
So how was the experience with you working with an actual company?
Yeah, very nice. Actually, Lawrence actually did a sanding at the company itself by hand. So we know hands-on the difference between how our program would impact their daily life at the company by making it automated instead of working by hand manually by the labor.
Yeah.
You want to add something?
Yeah, I think it was, I really liked it for working for a company because you have like a real goal. So if your program works, for example, they receive something they can progress on, something they really want, for example. So you're not doing something, which has something fake, which has no purpose. So it's really necessary for the company. So I really like doing that.
But I see Jeroen standing over here, so maybe we should ask him as well. What do you think?
Yeah, go ahead.
Let us hear.
Sorry to put you on the spot, but
no problem at all.
Yeah, how did you experience this project?
Well, all the credits for this team because they built a very important shackle of a long chain of technology in our company. Because automation is not only the mechanical part, but of course also the software and the IT part. What this team managed is to make the human interpretation of color recognition digital. So for us, this is a very important step forward for the next chapter, and that's to integrate this in a full automated test system, or a full automated sending system, I have to say.
Yeah, because why is an automated system so important for Spectrum?
Well, on a yearly basis, we have approximately 12,000 man-hours just sending, and it's very hard to find people for it. So if all these vacancies stay too long open, and our specialists in the composites or in the painting spend their job on sanding, it makes it worth to automate that general or that generic process in our craftsman process. So automation is for us the way out to grow.
And was it the first time you interacted with Inholland in this way?
Yes, in this way, not with Inholland itself, because we work together for many years, but working with two teams, because we have also team 19 and team 1 altogether, so in total 10 students. We had also 3 students of HVA, Amsterdam, and 1 of Windersheim, so it was quite a large team. But the whole setup was different, and the benefit for us is that we made quite a lot of progress in a short time frame. So instead of having 1 or 2 students on one subject, now we had 14 students. So for us, it was very good format.
Yeah, so a new format, but a successful one.
Yep. So I'm very curious about second half of this year, if we can continue it like this.
Because you'd like to continue this project in the same format, or are you taking it internal?
No, preferably in the same format or in a format like this. More students, more capacity, more knowledge, because it's also a matter of knowledge sharing, because talking together, working together, it brings more ideas than you can imagine when you work on your own. And that works for us as a company, but it works also the same for the single student. So if you can be part of a team, it's always, it gives much more pleasure.
Did you struggle a bit with the corona limitations?
Yeah, of course it affects us a lot because we are in the middle of aerospace. We see a direct effect on the workload. So we spent the COVID time in being better and not being bigger. And this a part of it.
Yeah, and the students interacted online, or were there some actual meetings as well?
No, not only online, but they also visited quite often the company to see what they built and to see how it interacts with the automation system itself, and also to see the other students. So it was, although it was just limited by COVID regulations, it was a very good cooperation.
Yeah, great to see.
And they gave us a presentation last Friday, said, well, this is a really good job, you need to join Specto to continue. But I'm afraid they do not have the time for it.
Great, that's a great compliment.
Yeah.
Okay, well, thank you very much.
Okay, very good.
Okay, I think we're going to find the next group. Thank you very much. Yeah. Ruben, are you going to give us a quick break? Yeah. Okay. Perfect.
Great.
Okay, I think we're back and we're here with group 16. I worked on an electrical system, so maybe you can quickly introduce yourself and explain what you did.
Yeah, I'm Martin Moy from Team Spark, and we were assigned to basically make the electrical wiring interconnection system for Dragonfly, which is the wiring harness for all of the avionics and the flight instruments in the aircraft. And so we were given a couple of components, and we were told, like, good luck, make sure that they fit somewhere in the aircraft and that they're wired up and that they work perfectly as they should, and reliably, of course. And so that's what we did. We decided to place over here. They would be in a bracket on the real aircraft.
Yeah, so this is behind the dashboard.
Yeah, it's behind the dashboard indeed. In the front here we have the AFIS, which is basically shows all your basic instruments that you need. It shows an altitude meter. Right now it's about 155 feet. That's because of the environment we're in right now with temperature and stuff. It's calibrated to think that we are 155 feet right now. As you can see, this is the sensor that tells you the position of the aircraft itself. So if this is turned, then you're going up or down, or from left to right, or you're rolling. And so we made sure that we wired all of this up, and we made all of the connections. We made sure it worked. We had to research some of the materials, and it works, and we're happy. So
what was the biggest challenge that you faced during this project?
The biggest challenge? Oh, that's a good one. Do you have any ideas?
I think something must have been difficult. It could not all have been easy, right?
Well, yeah. So the whole designing the actual circuit behind it, connecting all the different parts, seeing where we needed to put in some circuit breakers and such, that was quite difficult. And then finding the right shops for the right components to deliver to us for an alright price and with a decent time range. And then during the manufacturing we ran into a bit of a problem that we didn't have one of the tools that we really needed to have to assemble the whole thing. And that ended up taking quite a while, so we only finished it recently now. But in the end it still worked out alright and ended up as a working system, so we're quite happy with it.
Yeah, happy with the working system.
We're happy with the working system.
Okay, and what's the next step? Do you know?
Well, like some of the things is that for now we only bought one wire type. We actually needed some shielded wires in there, but they were super expensive, and then we'd have to buy 100 meters of wire to use half a meter of wire. So then, that's one of the things that would still be changed, or you would still want to change before installing it into the actual aircraft. And it's also in this dashboard, there would also be some tablets placed for more for the engine systems, for the information to be presented. So aside from this system, there are still some things to work on, but that was outside of our scope, and
Yeah. So is this experimental project, or I see some drawings as well. So maybe you can tell us a little bit about your approach, your process you went through.
So I can bring it through here, maybe quickly. So first we designed a more basic system. We just, how would we need to connect the components? Some of the connectors are already on there, what we would be using. Over here is the powertrain side, which is the other groups. This was before we had officially split it, and then we focused on the avionics side. So from there we would go into fully designing the circuits of it all, making sure every connection was in place. We knew what we wanted to build and how it needed to be built. And then, from there, the panel of where everything needs to be placed. Here, the switches, here, the EVIS, the radio and transponder control. And then, we had this nice panel that was already built to work with, which made things easier. We went to go look at the actual aircraft, measured how far or how long our cables needed to be with the piece of string from every component to every switch to, exactly figuring it out so we could order all our components. And then, from there, the routing of the aircraft. We had some firewalls to deal with and such like that. And then we went into manufacturing it all, and it quickly show some in the pictures. We did some testing with the multimeter to make sure all of our circuits were connected. There's no unintentional current transfer in between parts that aren't supposed to. Tested the switches to make sure if the switch is off, it really is off. And then, it took some time, but we eventually finally managed to have our entire system in place.
So this project will end up actually being used, because the Dragonfly is an actual project for Inholland?
So they are trying to make the Dragonfly airborne, and they're testing it this summer. It's actually testing this summer. So they want to put the system into the aircraft. They want to make a new panel, and I think some more things need to be changed about the aircraft still to fix it up. But this system should be used within the aircraft this summer.
Yeah, so the placement of the instrument is very important. Did you validate that with an actual pilot and consider human factors?
Yep.
Yeah.
Yeah, so I know a couple of pilots myself, and so I showed them a couple of the pictures, so the placement of the instrument panels, the placement of the controls as well is very important. And we had good feedback from them, and with that feedback we placed them right where the pilots would expect them to be, and that's how we decided.
Yeah, did you invite somebody at the end to
we did it
review
online, of course, because that was prior in the COVID times and stuff. But yeah, we did discuss this with them, and then they agreed, or at least when the final design they agreed with how we place things. So.
Yeah, so you did this with Inholland itself, so not with an actual company. So who was your end customer in this
end
case?
customer is Inholland itself, or at least the supervisor over here.
So it's Mark, right?
Mark Ommet, indeed.
Yeah.
He's our company customer supervisor, indeed. And so if he wanted to change something, then we had input from there and we changed something. Or we didn't, but we had a good reason for that. So.
Yeah. So what did you think the value is of doing such a project in this setup?
For ourselves or for the customer?
I think for both. Yeah.
Well, for ourselves, first of all, also one of the biggest difficulties, I think, was that previously we didn't have a lot of electrical engineering experience prior to this. So we learned a lot to create a manufacture and work with the electrical components. And then I think for the company or the customer, it's very important to see that, all right, it may look very easy on paper, like line 2 components and that's it. But there's a lot more to it, and there's a lot you have to think about regarding requirements or safety issues and regulations. So, or pilot input, as you just said. So there's a lot to it.
Yeah, perfect. So this was one portion of the project. You split it up. The next project is right here.
Yep,
next to us. Can you maybe introduce us real quick, and then we can.
Well, they worked on the powertrain side, so the electric motors and the input from there and the controls. And that's way more heavier stuff than we worked on. So
okay, well let's hear more about it.
Yeah.
Thank you. So the second part of this project.
Yeah, the second part after the avionics. We're Group 9. We're working on the electric propulsion of the Dragonfly behind me. And what we have here is a test setup for part of the wire harnesses we made. And in front is also an interactive overview. For example, if I switch the power switch, you are able to see that the LEDs are lined up. That means that the contactors here are closed. Electricity flows through to the engine, and the system is working. And we worked on to make the Dragonfly has 2 engines, and we tried to make them as redundant as possible. And to do that, we have actually separate wire harnesses per engine. So they don't interact with each other. We also have very large fuses, as 350 amperes runs through the system. You can switch between them. And as visible here, also have very thick wires for the Dragonfly.
So, was this a project that was easy? Was it difficult? How did you experience it?
I would say it is very new in aviation. Electric flight isn't really done yet. So we had to figure out a lot of the more like electric vehicle like components. And there was a lot of searching, seeing what works and what actually works with aviation regulations.
Yeah. And you have other team members here, so how did you split up the roles?
We had a sort of a step plan, like first look at what kind of regulations are there, what actually can be done about EWIS. Also had some contact with Fokker Elmo and they advised us. And after that, designed the system, iterated on it, tested it, and it was all done simultaneous.
Perfect. So yeah, how about you? Right? Part of the team?
Yeah, I think the most difficult part was part selection. So a lot of components are not yet certified for aircraft. So for example, our power cable is certified for electric cars, but not for aircraft. And one of the, I can show you here. For example, here we have insulation. That's PVC and it's not rated for aircraft. Normally they would use Teflon, which has better fire resistance. And also the copper here is bare. And normally you would want this tin, so it has better resistance against vibrations, for example. So yeah, that was a challenge. And most components we used are not certified for aircraft, but it is okay for experimental aircraft.
Yeah, it's also something new, so it's logical you cannot get certified components.
Yeah.
Did you also look into what you need to do to get it certified?
You would need to upgrade to better components, but it's very expensive. So we did give recommendations for better cables that are certified for aircraft, but you would need to increase the budget, so it's not very feasible.
Yeah. So who else is in the project? It's you as well. So what was your experience and what did you learn?
Yeah, by the way, this was a very new project to work on. From the beginning of the project, we didn't have a lot of experience with electronics, so it was learning during the project. And yeah, I think we are all happy with the progress we've been able to make. We came up with the concept design and then the whole design of the system, and then we have this safety concept to prove that our overall design works. So yeah, it was an interesting project, and I learned a lot about electronics and some of the regulations with aircraft, not just aircraft, but electric propulsion, system of an aircraft. So it was a really interesting project.
Yeah, so what systems did you use, or what processes did you use to design the system?
Well, our approach was to first start with the requirements. What were the requirements for the system? So we started from that, and then we also looked at the component that that the Dragonfly already has. So we look at the component, and then what component should be connected to that. So we did the research, and the next step was to come up with the concept design. So yeah. That was sort of the how do you say it? The steps that we followed to complete the project.
Yeah, perfect.
Yes.
So you had some guidance.
Yes.
From
this is our school supervisor.
Yeah. Gerben, right?
Yep. Yeah, I've sort of been the supervisor for both these two groups, and it's been an interesting ride with them. I think it would be honest to say that both teams, it was not their first choice to start with this project, because I think also that they were not very familiar with these electronics in aircraft. But then it was very interesting to see that now I see in both teams that students are really passionate about it. They really got a lot more interest into the subject, and I think also it's giving a great contribution in a innovative development in aviation to electrify small aircraft and to get involved in that. So very exciting, both for the students and for us at Inholland.
Yeah. Did you have a certain expectation at the beginning of the project?
Well, actually, we worked together with Fokker Elmo. And when we spoke with Fokker in the beginning, of course they have a lot of experience in this, and they were, I think, very critical about what our students were able to do within the limited time they got. So going by the experts, we had reason to believe that they would not really get very far. And I think if I see what they were able to do, I think they definitely went beyond their expectations. So I think we all can be proud of what was done.
Yeah, so working in this type of a project is
Yeah.
different than a graduation
Absolutely, yeah.
program.
Yeah.
So what do you think the advantages are of working in this format with companies?
Well, one of the real differences is that now students have been working together as a team. Graduation is mostly one student working for a company, for example, and now it's much more working in a multidisciplinary team, so students have different roles. I think in both teams, one of the lessons learned is how important communications are, to communicate not only within the team, but also with the other team who are working on a related subject, and also the communications with the industry. So communications, most of all, is one of the things that was the real learning objective here.
Yeah, can somebody maybe explain a little bit about how that was, the communication aspect of this?
Yeah, you did communication, so
Could you repeat the question?
Oh, you have to communicate with companies, with the other student team in this case, with a mentor that has certain expectations.
First of all, we sort of set up a lot of meetings with Fokker Elmo, with supervisor. We set up a different meeting with the other team, also with the cooling part of the Dragonfly, because they also, of course, have integrations into the electric system. That was mostly done via email, see when every team is available. And apart from that, communication with Fokker Elmo, if they had some kind of cable recommendation, they sent us kind of cables they wanted, and we responded to that, and the correspondence flowed from that, mostly.
Oh, great to see that interaction between companies and yeah. So next steps. This project will get a continuation. It's not ready to be built into Dragonfly just yet.
Not yet, but I think we made some good steps ahead. I believe even during the summer vacations, there's going to be students working on it, not just on the electronics, but on the rest of the Dragonfly. And I'm sure we are going to continue with this. And hopefully we do get to the point where we can get the Dragonfly to fly electrically.
Yeah, so a great opportunity for the next group.
Yeah.
And will that just be in the same format, or could it also be a graduation project?
I can definitely see possibilities that we get graduating students involved. It can be partially in the same format, maybe internships, and maybe also from other universities. I think we're open to that.
Yeah, perfect. Okay. Well, thank you.
You're welcome.
All right. I think that's it for today. I'm looking at Ruben. He's pointing somewhere. Okay. Oh, there's one more group. We're gonna do one more. Okay, perfect. Yeah, sure. Which one though? Let's see if somebody's ready. There's somebody here that's willing to do a quick interview? Maybe you guys. Oh, that's not yours. Okay, maybe. Yeah. Is anybody available here to do a quick interview? I think we're going to take a quick break, Ruben. We'll be right back. think we're back. We found the next group that's willing to do an interview. So, yeah, can you quickly introduce yourself and
hello everybody, I'm Akif Egbelivan. I'm from Group 11, and we have made a project in collaboration with KVA, where we designed a detailed design and designed a verification plan for the aileron, where we use thermoplastic composite to make it. And it is used for the Dragonfly over here. Now first we have set up the load cases, which we have got it from CSVLA, and then we used then we designed the lugs over here.
So what are lugs? Can you maybe explain a little bit about the
Well, the
you know
lugs-
what the aileron is, but
Yeah. Well, this is what a lug looks like over here, and it's connected to the aileron over here to connect it with the wing of the Dragonfly over here.
Yeah, so the pivot points of the.
It's pure for the connection.
Yeah.
So after the stress analysis was done, we implemented topology optimization for the lugs to reduce cost and mass. After that was done, we have endured some testing where we implemented the lugs between the spar, and then we couldn't have welded as it normally would have been.
Because this is thermoplastic material, right? So that's the.
Yeah, simply because the tool wasn't available for this application. Instead, we have used glue, and this glue is it makes it special because it is an adhesive between PPS resin and titanium, which are the lugs, which are quite difficult to bond each other. Well, we have achieved a pretty good result, as if I can say it myself, where we are very proud of. You can see it here. Because our requirement of the CSVLA is when you use an adhesive to bond two connections, is that it has to fail in a matter of a mixture of cohesive and adhesive failure, and that is what we achieved right here.
Yeah, I see some actual prototypes here. Maybe you can show us?
What do you want to see exactly?
Well, what?
Out here, the lugs designed.
So this is using 3D printing, or?
This is used by 3D printing, but we want to 3D print it in titanium. This is still kunststof.
Yeah.
And then we implement it in the assembly using glue. And then it was part of the production of the spar, where we used the fiber, and we firstly hot pressed it to get some stiffer material, composite material, and then we had to get it in shape, and that's why we got the mold, where we attached it and heated up to some 320 degrees, where it would get soft enough to bend it and get it in shape. That's where we use this. And this are set up for our hot press of the silicon part. Now, when it's to the degrees that we wanted to, we could press it down here, where we get eventually a shape using the hot press, and this has turned out really well, as I can say myself. So it's basically almost all parts we need to assemble the aileron. We are still waiting on production of the skin and a mold to be ordered, and that's where we are nearly done.
Yeah, so the assignment was to develop a thermoplastic aileron.
Thermoplastic composite aileron, yes.
Yeah. So how far did you get in the process, and yeah, where did you have to stop?
Well, the tricky thing is that the mold that we have ordered at the company, it turns out to be longer than we had expected, making us not as flexible anymore in time as we were. So it's basically really the shipping time of the company what held us busy, because we had to wait on the adhesive glue too of the companies. It turns out to be a really long shipping time, which eventually couldn't make the finish the project.
No, so you faced the delay and
We
had some
faced
setbacks.
really some delays, yeah. That's.
Did there also things go better than you expected?
Yes, and this actually the lab share test, because of the PPS there isn't really known properties, not as much as we can work with, but using the glue on the spar right here, can you see it? Oh yeah. And get it in the bench. It turns out better to be expected because the force when it got critical, which failed, it was like 3 times higher than we actually needed to.
Okay, and what is the value of this project, you think, for your education?
We really learned some key values as optimization and using stress analysis on topology. It learned us to be as cost productive, efficient as getting and finish our products. After, it was really nice to get a project from a company as a school project, which almost every year is the same, but a project from a company is really nice to have, and it gives more interaction with the company. You get your hands on things, and it's a really nice feeling to have making a project, which gives me more experience in the working field than just theory.
Perfect, thank you.
Thank you too.
So, thank you, and let's move on to the next one in the last presentation. I think we have Twan here, right?
Yes.
Yeah, that's you. Okay,
Hi.
perfect. So this is your project.
Yes.
At least I think, how many members did you have?
Besides me, 4. So we had Ismael, Luc, Alvaro, and Rutger. I don't know where Rutger and Luc are at the moment. Alvaro is in Spain, so that was a bit of a struggle during the whole project, working with people that aren't in the Netherlands. But yeah, our project was focused on the laser communication. So Ion Orbit, the company from Mr. Laan, presented a case to us in which he wanted to investigate the possibilities of laser communication between 2 terminals. And yeah, this had several benefits, like laser signals can be intercepted, so for military grade and stuff like that, it's very nice to have. And it's way faster than FM and AM data transfer, which we use now. With the optical systems reaching speeds up to terabytes per second, so that's a bit faster than we currently have with the radio frequencies. And within the future, we expect to have even more use of data transfer, so it's a welcome invention. And yeah, for our project, we basically made a proof of concept about the laser communication. We had a small budget, and we had to work with that. And the way the system is built up is we have a laser diode, which in which we put in a converted signal. If you can see on the screen, maybe.
Because what problem did you try to solve in your project?
Communicating with laser communication between our group and the group on the table behind. So the goal was to initially to transfer a picture to the other group, wireless and with use of laser communication. That didn't work out as planned, as we didn't have any experience in the field of optics, and it was a bit beyond the things we learned at school, which also made it challenging. But eventually we had a successful data link with the other group on the balcony on top. So from
so you tested the laser system actually in this building?
Yeah, like you can see here, we were standing on the top of the balcony here, and we have a serial monitor in which we type in the text we want to send, the case we want to have now, like you can see on the screen to the right. When we press send, it gets converted into bits, so zeros and ones. And those zeros and ones translate to a laser signal of on and off, a 1 meaning a high, so the laser will be on, and a 0 will be off. Then the other group receives the signal, and they use a photodiode, which is basically just a solar panel which measures the intensity of the light it receives. And that photodiode, you can see the reading on the screen on the left. You have a basic reading of all the environment light you have. But when we shine when it receives the laser signal, you see that the signal becomes high. And we wrote a code for that every high signal is translated back into a 1 and every low signal into a 0. And that eventually comes back as text again, and we can both receive and send on both terminals, so they can send something to us and we receive it, but we can also send something back to them.
So you had some setbacks, it was a little bit more complicated than anticipated, especially the optical side. Did you also have some things that went a lot better than you anticipated?
A lot better, not exactly, but I think when we eventually got the parts, the testing went on quite quick. Within a day we could easily do the test we wanted to. But since the whole Corona pandemic, most companies couldn't deliver the parts on time, and we have some specialized optic components into the system. So it was waiting for those parts to be delivered.
So what did you do in the meantime?
Writing the technical report, like the calculations behind all this, which was also a bit new to us, but I think we managed at the end.
Yeah, so you have a system now that can communicate with each other?
Yeah.
Yeah, what's the next step? What's the application of the results that you...
we tested it now on a separation distance of 40 meters. I think for future iterations of the project, this should be ramped up because we eventually want to use it to communicate with lasers in satellite orbits. So next steps would be replace the laser with a more powerful infrared one. We now use a visible laser due to it's more easy to align with the other terminal. You can imagine that the terminals or the lasers have to be perfectly aligned to get a good signal reading. Future iterations must also include a motorized mounting system or a more precise way to guide the light through the photodiode using advanced adaptive optics. So much to do before this eventually can be used as a commercial product.
Yeah, and what did this add in your education, working in this format?
Like I said, I didn't have any experience in optics and little in coding, and that were the two primary factors of this project. So learned a lot about those two work fields.
Yeah, and how about working within a team, but also with a customer in mind? How was that?
We already had some experience, or at least I had some experience in working in a group and with clients. So it wasn't that new to me, but I think we had a good client with Erik, with Mr. Laan as also being the client and the supervisor. So we had close contact with him, and if we had any questions, we could ask him, and he immediately responded most of the times. I think due to the Corona crisis, it was a little bit challenging to do the practical stuff. We have delayed it for a month before we even could start because the building wasn't ready yet. But now everything is coming to an end.
All right.
I think we managed well.
So satisfied?
Yeah, really.
Rick.
Yeah.
Rick.
Okay.
Arnold needs to have a couple
we're gonna
seconds.
finish up. That was it. Thank you very much.
Can everyone hear me? Yes. All right, everyone. It's 12:30. I think the project market is now almost done, or nearly done. And I would like to invite everyone for lunch, which you can see on the tables over there. There's a bag. There should be a bag for everyone. So feel free to grab a bag and enjoy your lunch. And then after the lunch at 1 o'clock, we will continue with the group sessions where you will sit down with your university supervisor to hear the evaluation of your project. So back in half an hour. Enjoy your lunch.
Is there a way to go down?